Welcome back. So in this video we'll just continue from where we were last time then, talking about IP addresses. And right, quick overview. So we're going to recap public and private IP addresses. We're also going to talk about ports and how they relate to the protocols being used. Right, we'll also talk about network address translation, NAT, and that's going to be how we convert from a private IP into a public IP, and likewise vice versa, right, so public to private. Right, we'll also look at static and dynamic IPs. So a static IP being an IP that doesn't change, whereas dynamic IPs, alright, so dynamic IPs being an IP that does change. For example, when a user turns off their device, well, probably after a certain amount of time, if this is not sort of connected back to the network, well, then we would probably, so then we would want to reallocate that IP, right, to a different device that's, trying to use it. Right then, finally, just the dynamic host control protocol and DHCP, and basically this is just how the dynamic IP allocation works, where you'd have the DHCP server. That's going to store a list of all the IP addresses. Alright. So that's going to store a list of the IP addresses that is currently allocated. Therefore, when a new device connects to the network, well, then the DHCP server can allocate an IP address that is not allocated to any other device. Alright, so we mentioned this then, there was a shortage for IP version 4 addresses, and that's because IP version 4 only uses 32 bits, right, hence it only has about 4.3 billion IP addresses. However, since we said currently there's about 8 billion people on the world, and most people have more than one device, so a lot of people have let's say a phone, a laptop, a desktop, right, maybe a games console, maybe a car that's connected to the internet. And then this is also not even considering, let's say, I don't know, company devices, things like government devices, things like, let's say, CCTV cameras, all sort of sensors, right, monitoring things. So I think there's definitely So in reality, we probably need 100 billion IPs. Right. So to solve this, then a few approaches were used. Right. First is subnetting, and hopefully people remember this because we've talked about this in the last video. Now, previously, they used the class-based IP system, so class A, class B, class C. Now, the problem with that is we couldn't choose where to actually kind of separate the so we couldn't choose where to separate the 32 bits right into the network ID and the host ID. So we had situations where we might have a network that only needed 1,000. Alright. So we might have a network that only needs 1,000 hosts, but either we had to have many class C networks, right, or we'd have to buy a class B network, and class B, I think that was 65,000 different IPs. So in that case, if we're only using 1,000 of them, therefore 64,000 of those IPs just going to be wasted. So the way subnetting solves this is, subnetting, this lets us choose any bit as being the split between the network ID and the host ID. So if we only need 1,000 IPs, then we can probably have it where, let's say, we'd have 22 bits for the network, and only 10 bits for the host. And the reason 10 bits, because if we think 2 to the power of 10 is 1,024, or therefore 1,024 is greater than 1,000. So so that's going to be sufficient. Right, then if we look at this, so this is going to be new. Right, private IPs and NAT, network address translation, and that's going to be what we look at today. We're also dynamic IPs while using DHCP, and again, so we're going to look at this today. Right, let's just look at these then. Right, so the first one, network address translation, NAT. So rather than each user, rather than each user, I guess, each device, right, having a public IP address that had to be globally unique, then instead we could give the network router a globally unique IP address. So let's say you're on, your home network. Well, in that case, your home router is going to have, the globally unique IP. However, alright, so let's say each device on the network is only going to have a private IP, and that's going to be unique for that network, but it's not going to be unique for the entire world. So this is why if you look in a device's connection settings, right, either in a GUI via the sort of, I don't know, Windows menu, or Mac menu, right, kind of whatever operating system you're on, or for example, if you're on Windows, Windows you can use the command ipconfig/all. Of course, Mac, Linux, they're going to have their equivalent commands to see this. Then you'll often see a private IP like 192.168.0.1. Now, if you look at your network, you're probably going to see the same kind of IP. Maybe even an identical IP to this. So the thing is, since this is a private IP, this only has to be unique on your particular network, Yeah, that's why, you can have the same private IP as, me or, yeah, other people watching this video. Right, okay, so here are some of the ranges then. Yeah, okay, alright, so not some of the ranges. I think these are the only ranges for private IP addresses. So, yeah, okay, alright, so basically there's going to be three kind of ranges of IP addresses that are designated as being private. And these you can't use as public because yeah, okay, so basically they're just reserved, right, for being private. Right, now this one's a bit tricky. They wouldn't actually ask this in the exam, although let's see if we can do it anyway. So, right, what would be the default subnet mask for each of those address ranges be? And right, therefore, which can have the most devices? So basically, we just want to think, well, which part of the IP is staying the same and which part of the IP address is changing. Now, if we look at the first one, so the first one here, yeah, this 10 is staying the same. But then if we look at all of these, these zeros, right, they're changing into 255s. So what we can say then, yeah, so if it's staying the same, well, then it means it's the network, right? Therefore, well, that's going to be 255 because, yeah, so these first 8 bits are staying the same. But then if we look at these, well, since these are changing, then that's going to be the host. So this one here, this is going to be what, 255.0.0.0. Yeah, that's going to be the subnet mask. Right, this second one I'm going to come back to because this is quite tricky. Right, then if we look at the last one, so the last one we can kind of use the same technique. Now here then we see, yeah, okay, alright, so the first two groups are staying the same, right, 192.168, right, the last two groups are changing. Right, therefore here then the subnet mask, well, it's going to be 255, right, dot 255, yeah, 5, right, yeah, dot 0.0. Right, hopefully that makes sense. Now this, yeah, okay, alright, okay, so this middle one is a bit tricky when we don't have a split, on an 8-bit boundary. But basically the way we can do it is we can kind of just write out the binary of this and think about, what's staying the same. Now, I guess, well, 172, I mean, that's quite easy because, well, yeah, that's just the same. So, well, okay, so let's write 255 there. Right, so what I'm going to do, I'm going to write 16 in binary. So 16 in binary, and let's just do this here. Right, so if we're thinking, well, 128, obviously no 128, no 64, no 32. Right, okay, alright, yeah, okay, right, so here, right, so there will be a 16, right, but there won't be an 8, won't be a 4, won't be a 2, won't be a 1, right, so this should be 16, right, then if we want to get a 31, well, 31 is going to be, 16 plus 15, so yeah, that's going to be all of those, and let's just add in those leading zeros there. Right, so effectively what we can say then is, if we look at this, well, yeah, okay, alright, so these 4 bits are going to be the same. But if we look here, well, these are going to be the ones that are changing. So because that's changing, well, then we want to think, yeah, what are these going to be in binary? So that's 128, right, plus 64, that's 192, right, plus 32, that's going to be 224, and then, yeah, plus 16, all right, so this should be 240. So then what we can say, well, here is going to be 240, and then if we think here, well, since these are changing, right, well, then again, it's just going to be, right, 0, 0. Right, okay. So I think maybe I've seen it once or twice where they've asked a question like this. So they might give you a sort of range, and then they might ask you, yeah, what's the subnet mask for this? I mean, they're definitely not going to give you one where the split is not on an 8-bit boundary. Okay. So that's going to be too difficult. Yeah, and then I guess right there's just the answers. Right, so what we can say then, the private IP address ranges are hence listed from having the most to least available device IDs, or yeah, host IDs. So again, yeah, so this first one here has the most device IDs or host IDs. And the reason for that is, well, if we look here, we've got 24 bits representing the host ID. Right, if we look at this one, so I guess this one has 4 bits here, and then 8 plus 8. So that's going to be 20 bits, yeah, for the host ID. Obviously, this one here, right, just 16 bits for the host ID. Okay, then it says one screenshot was taken from connecting to the classroom Wi-Fi, and one was taken by connecting to the school-wide Wi-Fi. And which do you think was which, and why? So I would say pause the video, right? Pause the video, have a look at all these details, and see if you can figure out. Okay, so if you've thought about that, then what I would say, well, if we think here back to the IP ranges, now if we see here, so 10. Now, if it starts with 10, then, well, this private IP range is going to have, the most possible devices. Whereas if we see, 192, right, yeah. So 192, well, this is going to have kind of a fewer total amount of devices that, that it can support. So if we look at this, well, if we think a classroom Wi-Fi, I mean, in a classroom, generally, we don't need that many different, devices connected to it. Whereas if we think, all right, yeah, so here, okay, so if we're thinking the entire school, well, then of course we're going to need a lot more different devices on that. So if we look at here, the IP address, and this is going to be, well, the private, or, local IP address. So since this starts with 10, well, this therefore is going to be the school-wide Wi-Fi. Whereas if we look at this one, well, 192.168.1, right, 109. Well, since that starts 192, right, 192. Well, then of course it's going to have fewer possible addresses available. Therefore that's going to be the classroom Wi-Fi. So hopefully that makes sense. And I guess right here then it's also highlighted the default gateway and also the DHCP server. And I guess the thing to note is that if you look at that, well, that's also of course on the same network. And when we say the gateway and server, well, so when we say, the gateway and DHCP server, well, most likely in this case, that's also going to be the same as the router. Alright, however, if we look at this, so the DNS servers, right, they're actually strange because, well, okay. So actually here, I've changed it, right, just for privacy reasons, although these are actually on a different network to, this private IP here. Now, if we think, well, the reason I've changed this is because, well, so actually these DNS servers, well, these are going to be the ISP's DNS servers. And if you can actually, search up this IP address, well, then you can, geolocate people. So that's kind of the key thing to note, that DNS servers, so, right, the ISP is going to have its own DNS servers. But if we look at this, well, here we see the router. So the router is also acting as a DNS server. Now, DNS we haven't covered, right, so DNS we're going to cover later. But that's something you can mention. Well, DNS is a hierarchy. So you don't just have one DNS server. You actually have many DNS servers. And actually, so this is kind of going into more detail. But your computer is going to have DNS records. Then, well, your browser, right? Then your router. Then it's going to be the ISP's DNS server, right? Then it's going to be these kind of global DNS servers. Right. So that So that's just some of the different levels. Alright, so I think, that's just what we said. DNS again, right, that's going to be, well, I think, tomorrow's video, right, next video. Alright, so first then, if we just, so if we look at what would happen if everyone is using public IPs, and again, right, alright, so this is generally not what's being used because, well, so the problem with this is, well, here we're going to use up all of the public IP addresses. Right, so the problem with this, well, one, it's more expensive because, well, everyone needs to buy their own public IP. And I guess it's supply and demand, right? If we only have 4.3 billion IP addresses, well, therefore they're going to be more expensive because, for example, ISPs would have to buy, the IP addresses. Right, it's also, kind of unnecessary wastage. I guess, well, waste of public IP addresses. Right, so in this case, well, since each end device, since each end device has a globally unique IP, well, that's going to be bad, right? Public IP. Right, so this is where we're going to look at NAT, or network address translation. So, alright, so as mentioned, well, it's going to convert from private IPs to public IPs, right, and likewise the other way, right, public IPs to private IPs. And if we look at this, well, here we see the router has the public IP, and again, the reason we know that it's public is, well, because, so since it's not in the range, I think it was 10, it was also like 172 and 192. So since it doesn't start with those numbers, well, then we know it's going to be public. Whereas if again we think, well, 10, right, so 10, well, that's one of the private IP ranges. So the key point, well, router has a public, right, globally unique address, right, devices have private addresses unique only to that network. And the thing is, right, alright, so even though they're private, I mean, notice how they are still unique. So this one is, well, 1, alright, this one is 2, right, this one is 3. So you can say, well, so on their own network, they're going to be unique. Although what you could have is, let's have another network, I don't know, 67, or let's say 123, let's say 45, and rather than 67, well, let's go, .68. And let's say on this network, well, then you're going to have another device, and maybe this one is, I don't know, 10.0.0, let's say .1, this one, well, 10, right, 002. So here's the thing, well, alright, so here we see this one has, 10.0.0.1, right, here this one also has the IP, right, 10.0.0.1. However, since they're on different networks, as specified by this, the router's public IP, well then of course, right, they're not actually considered the same device. Yeah, and we'll see how that's going to work in a minute. Alright, so I guess first of all, let's just kind of have a break. Let's recap about ports, right? Make sure everyone knows what this is. So when a device receives data, then do you think it's going to be enough to tell what process or application the data is for? Yeah, okay. Right, okay. So, alright, so I think probably what they should say, maybe do you think an IP address is going to be enough, right, in order to tell, yeah, what process the data is for? Alright, so yeah, the answer for this is going to be no, and yeah, this is what ports are used for. So they're going to specify the process or the kind of application, right, that the data is used for. Or kind of, yeah, I guess sort of, well, I guess intended for. Right, so if you want okay, so if you want an analogy, we can say, well, an IP address is like the building or the house, right, while the port is going to be the specific room number or the person's name. Because let's say if you send a letter, I don't know, yeah, to a house or a hotel or a building, well, you can't exactly just put, the building name or the house name on it, right? Since, well, probably there's going to be, right, many people in that building. So then you'd also need to put, okay. So if it's like a flat, well, then what, all right. So I guess a flat, you need to put like the sort of, yeah, flat number, right, the floor number. You'd have to put what, yeah, okay. Right, okay, so again, you're going to have to, well, okay, the person's name, or the room number, yeah, etc. So hopefully that makes sense. Right, so ports, yeah, there's kind of two versions. So you can say, well, either hardware ports, so for example, well, LAN or Ethernet ports, right, USB ports, yeah, etc. Headphone ports. Yeah, as we can, see here, right, in this picture. Right, however, in this case, well, okay, right, so in this case, the ports we're talking about is going to be, well, the software ports. Right, they're not a physical object, right, effectively they're just an ID number, yeah, used so that data can be sent to the correct process. So let's just give an example here. Let's say we have this device, and if we just think of different processes, so I think, let's say we have some HTTP server. So in fact, let's say HTTPS. Now, if we're running a web server, well, usually that's going to be on port 443. Okay, right, okay. So 443 is the sort of, I guess, standard, HTTPS port. Right, let's say we have FTP. Now, I've actually forgot these. I think FTP, like, maybe it's 21. I'm going to put a question mark. Okay, so I think it's probably 21. And FTP, what the file transfer protocol, just used for sending and receiving files. Or yeah, I guess, well, okay, all right. Yeah, so let's say uploading or downloading files. And well, uploading being, sending to someone else. Obviously, downloading, well, yeah, receiving from someone else. Right, let's say, I don't know, maybe we have like SMTP, so yeah, is it, I don't know, simple mail transfer protocol, or yeah, maybe simple message transfer protocol. Right, this one I've actually got no idea what that is. Let's just say, I don't know, 999, again, question mark, right, not really sure what that is. And let's say SSH, right, so, well, okay, yeah, right, okay, so SSH being secure shell, and you're going to use SSH in order to remotely log into a computer. Basically, yeah, okay, all right, okay, so not necessarily a computer, right, just a device, right, it could be, well, it could be a computer, it could be a server, right, yeah, it could be anything. So you're going to use SSH to remotely log in and access the command line of that other device, right, just so you can run commands. And I think SSH, like, maybe it's like 22 or 20, or yeah, I don't know, right, okay, all right, okay, so let's say 20, right, again, yeah, maybe that's true. So let's say we have some data, and I don't know, the IP addresses, let's say what, 12, right, .34, let's say 56 and 78. Now the thing is, if we want, okay, right, so I'm saying, well, this is the IP address, of this device here that we've, yeah, sort of, hypothetically made. Now, let's say if someone wants to send something to the web server, well, they can't simply send it just to this IP address because, well, yeah, so then when this device receives it, well, how does it know, is this data for, this HTTPS, right, program or process? Yeah, is it for, this email process, right? Is it for the, well, yeah, SSH client, right? Is it for the, sort of FTP client? So what we actually need to do, well, if we're sending that, let's go, what, 1, 2, yeah, 1, 2, right, 3, 4, 5, 6, right, 7, 8. Right, then we also need to append the port number. Now, let's say if we go 443. So since we've added 443, well, this means that, yeah, okay, all right, okay. So these packets are therefore intended, well, of course, yeah, for this HTTPS. Right, likewise, if we send something else but put it, I don't know, yeah, port 20, for example, well, then, of course, yeah, these packets are then going to be, sort of, well, passed on, right, to this SSH program. And I think this here is super small, but if you look at this, I guess, yeah, okay, so I think here you can actually see, well, the remote port, so that's going to be the port we're communicating with, and well, the local port, so that's going to be, right, yeah, okay, okay, so that's going to be the port for this process on our device. And if we actually look, well, if we see 443, so for example, all of these are 443, I mean 443, right, 443, and again, hopefully you remember, well, 443, right, as we said here, HTTPS, and yeah, we can also see that here. Yeah, okay, right, so hopefully that makes sense. And again, just to recap, what hardware ports are used for, what input and output to a device, or yeah, to from a device, right? Software ports, what specifies the process that the data should be kind of passed on to, right, on a device. Alright, so here then's actually certain ports, and it seems I've completely messed up some of those numbers. Yeah, so FTP, well, that's 21, right, okay. Yeah, so SSH, right, that was actually 22, right, not 20. I mean, Telnet was similar to SSH, right, just, remotely logging into a computer. Although Telnet is not recommended because, well, Telnet is unencrypted. So if anyone, for example, has like a web server, or yeah, just any sort of server that they need to log in, well, probably they're going to be using SSH to log into that. Right, so 25, yes, simple mail transfer protocol. So I guess just talking about okay, all right, okay. So let's say, I don't know, you have like a Gmail address. Now, if that Gmail address is sending to, I don't know, like a let's say like Proton mail address, well, then the Gmail mail server is going to use SMTP in order to send that email right to the Proton mail email server. Then 53, the domain name system, or yeah, DNS service. So DNS, basically that's going to be how we convert from a domain name like google.com right into the IP address of Google. Right then, well, yeah, hypertext transfer protocol HTTP. I guess, well, yeah, I just kind of sending GET requests right to get a website. Obviously, well, okay, all right, okay. So then the response is going to be sent back, and the response, well, from the web server, that's going to be what HTML, JavaScript, CSS, right, yeah, images, video, audio, right, etc. Right, I mean, well, post office POP3 protocol, right, used by email to receive email from a server, right, and also IMAP, right, instant message access protocol. Again, basically just downloading emails. Now these are actually A2. Now we'll actually see. Well, this IMAP, right, this is the more modern version, yeah, of this POP3. Although again, this is A2, right, so don't really worry. And then, well, I guess 443, yeah, which is HTTPS. So that's what HTTP, yeah, using TLS or SSL. And actually, again, SSL, well, this is the, yeah, okay, right, okay. So I think SSL is going to be the deprecated one, or yeah, maybe it's TLS that's the old one. To be honest, I've actually forgot that. Like, basically one, okay. So it's kind of like IMAP and POP3, okay. So one of them is just the new version of the other. And yeah, I think I shouldn't have forgotten that, but yeah, I guess for some reason I have. Alright, so for example, if a server has a web server, then I mean usually it's going to be running on port 80, right? If it's HTTP unencrypted, or 443, right? If it's encrypted. Email, well, of course those ones. I mean, this doesn't always have to be true. I mean, in theory, there's nothing stopping you, from running a web server at, let's say, port 81. But the problem with that is, like, actually, let's say when you, right, okay, yeah, okay. So when you type in a domain, like, let's say you type, okay, all right. So let's go like google.com. Now the thing is, well, actually, what's going to happen? This, right, okay, all right, okay. So yeah. So one, using DNS, well, it's going to be converted into the IP. So let's say, I don't know, yeah, 1.2.3.4. Right, again, as mentioned, well, then we're just going to append the port number. So if we're trying to access over, HTTPS, well, then it's going to append, 443. But if for some reason we have, our HTTP, yeah, okay, right, okay. So if for some reason we've set up our web server where we actually have the web server listening on, 444, well, then it's actually not going to receive this data. Yeah, that's why generally, I mean, right, okay, all right, yeah. So if you want to make a website, kind of available for the public, well, that's why you're generally always going to want to use these kind of, convention, yeah, port numbers. I guess if the website is only for yourself, well, then of course you can really use any port number. Yeah, since other people don't really have to access it. Yeah, and I think that's just what we said. So if you type example.com, well, that's actually going to get kind of appended right with the port number at the end. Yeah, no, okay, all right. So that's just kind of what we've seen already, right? Just the different port numbers, yeah, the different processes. Right, so let's think then. So suppose my private IP is 192.168.0.1. Then if I send a request to a server, then how does the server know where to respond, right? Since, well, this IP is private and not unique. Well, yeah, okay, all right, okay. So when we say not unique, well, this is right, not globally unique, because as we saw with the previous example, we can have two networks with both 10.0.0.1. So yeah, right, okay. So this is kind of the problem. Right, so the way that NAT kind of addresses this, well, when packets pass through your router, then your router changes the source destination. Yeah, okay, all right, okay. So when we say source destination, well, that's the source destination's IP address, right, from being your device's private IP to the router's public IP. Right, if that doesn't make sense, well, we'll see a diagram in a minute. Right, then we have a record that maps the private IP and port number to the public IP and port number. And again, well, private IP port, right, okay, okay, so that's going to be your device. Right, the public IP, well, that's going to be the router. Right, so this mapping is then added to the router's, NAT forwarding table, right, network address translation forwarding table, so that when the router receives the response, or receives the packets from the server, then it knows which private IP and port, right, process to kind of forward it onto. So let's just look here how this works. Right, so let's say here then, I guess, right, this is our user, and the user wants to send a request to a web server. So let's say here, this is the user's IP, and in fact, let's change that color because it's a bit hard to see. All right, so okay, so this here is the user's device's, private IP, and right, this is just this, completely random, port number that they've just added, just to sort of represent, well, this is like the web browser that they're sort of using. And the thing is actually that each tab, so let's say you've got a web browser like Chrome. Now, if you've got 5 tabs open, I think what should actually happen is okay. So I think each tab is actually going to have a different port number, just so that when Chrome receives data, then it knows, of course, which tab this data is actually intended for. Or okay. So let's say rather than saying data, we can probably say packets. Right, and this here, this is the server's public IP, and again, here they're saying port 80, so port 80, just HTTP, unencrypted. Right, so what's going to happen then? Right, okay, so okay. So these packets are going to be sent to the router, of course. That'd be in this one. And if we see, the router, this actually has a private IP, which is just the sort of gateway, rather, kind of private IP for the network. But the router also has a public IP. And this public IP, most likely this is going to be assigned by the ISP's DHCP server, right, Dynamic Control Protocol server. Although I guess technically this could also be static, right? It could also be fixed. All right, so what's going to happen? Then we're going to make an entry right in the NAT forwarding table. So it's then on the private side, and the private side is just our device here. So it's then okay. So if we have packets right from this IP address, and right this particular port number, then we're going to send out the router. And if we think the router, that's always going to have the same kind of public IP, because that's just the public IP of the router. Right, however, okay. So the port number will change because, what you could have is, let's say you have another device here also sending to the router. Then we're going to need, let's say, a different port number, just to, differentiate the packets when we, receive them again. So hopefully that makes sense, right? We're just going to make a mapping from the private to the public. Again, we're just with the IP address and port number. I think that's just what I said. I mean, okay. All right. So if you want, you can just pause that, right? Read it again. Right. So this is probably going to be the response. So the server sends a response using the router's public IP and the specified port. Right. So here then, this is the server. So the server, that's this 4030 2010. Right. That's then going to be sending back to 12 13 14 15. And notice here that right here we are. Okay. So notice here then it's sending to this port number on the router. And since we've also specified the port, then we can look here and we can see in this public side. So since the packets we've received, match these details, then we know that, of course, right, okay. So then, of course, we know, we need to send it then to this IP address, and right, this port number. So then, of course, the router is then going to send it, and hopefully you can understand, how the device can then, interpret that. Obviously, right, okay, okay. So hopefully you can realize how the device will then realize that, based on the port number, why is it, okay. So based on the port number, it's going to know what process these packets are intended for. Yeah, so if that doesn't make sense, I would say, just sort of rewatch that process again. Yeah, just think how that works. Right, okay. So again, going from the device which has the private IP, while the packets are then sent to the router, right, and entry is made in the router as well. Yeah, NAT forwarding table. Right, and yeah, okay, right, yeah, okay. So if you see, okay, so the entry has the private IP and the private port, right? Then it's going to add the router's public IP and also the public ports, right? That's going to be sent to the server, right? The server is then going to send back, and of course, okay, right, okay. So then the router can then look at this NAT forwarding table again, yeah, just to map from the public packets that it's received, yeah, back to the sort of private device, or the sort of private IP address. Yeah, that these packets are intended for. Yeah, okay, hopefully that makes sense. Right, okay, so the final method then to solve this shortage of IP version 4 addresses is using dynamic IP addresses. Right, so just by the word static and dynamic, right, can you guess what these might mean? And I think we've actually mentioned this already. But hopefully, static IP addresses, right, just fixed, they don't change. Right, in contrast, dynamic, that means, right, yeah, okay, okay, right, so dynamic addresses, they can change. And they're also going to be assigned by the ISP, right, the internet service provider, right? The ISP, hopefully people know, but basically that's going to be the company that you're sort of buying your monthly internet package from. Right, so yeah, dynamic IPs, right, okay. So actually there's kind of going to be two. So your router is going to get a dynamic IP from the ISP, but then actually your device is going to get a dynamic private IP from the router. Yeah, and actually, let's say that again. Okay, right, yeah, okay. So the router is going to get a dynamic public IP from the ISP, right? Whereas your device is going to get a dynamic private IP from the router. Yeah, okay. Right, and let's think then. So, what kind of device might require a fixed IP address? So, kind of an obvious one, which is going to be servers, right? Web server, file server, email server, database, right? Print server, right, etc. Right, and what would happen if they did change? So hopefully people can think, well, let's say we have a website. Now, yeah, okay. So if we have a website and let's say we're thinking that the website has, I don't know, yeah, the IP, right, 1234. Well, if suddenly the IP address changes, like if we're still sending packets to that same, IP address, well, then of course it's going to be someone completely different that's, receiving that data. Yeah, the actual website that we intended for, right? Yeah, okay, yeah. So that website is not going to receive those packets. And I guess just another example on an email server, yeah, it's kind of the same thing, right? If the IP address changes, the packets would no longer arrive at the correct server. Although the thing to note, right, there are protocols like DNS that do allow IP records to be updated, since sometimes we have to. I mean, sometimes, let's say, yeah, okay. Let's say sometimes you want to migrate your data from one server to another server. Now, in that case, you're probably also going to have to change the IP address. Yeah, in particular, if you're sort of changing company, right, changing host. Yeah, so I guess as a kind of simple example or simple analogy, it's kind of like sending a letter to someone. Well, you don't want the person to be, moving house every day because, well, then you're gonna, yeah, okay, okay. So then you're not gonna know what address to send it to. Yeah, so hopefully that makes sense, right? Yeah, okay, yeah. So hopefully that makes sense why static IP addresses can be quite useful. Since the IP is not changing, right? Therefore, we don't have the situation where we're going to accidentally send. Yeah, okay. So we're not going to have the situation where we accidentally send packets, yeah, to an IP address that's no longer hosting, right, the content that we're trying to send to. Right, okay. So when talking about servers, static IP addresses can also be considered more secure, and yeah, try and have a think about why that might be. So let's assume if the IP address of a popular website now points to a random user's machine and millions of people are trying to access it, let's say, I know, yeah, Google's IP address, right, suddenly changes from whatever it is, to a new IP address, yeah, just to, some random person. Right, then instead, well, if the person, figured this out, well, they could instead, send them, let's say, a malicious version of the website. Let's say, yeah, like, okay. So kind of like a phishing, right, farming attack. Yeah, or they could just send the malware directly. So yeah, that's obviously going to be a security, vulnerability. Right, in contrast, well, if an IP address is assigned to a specific company and never changes, then users can probably have, more trust that it's going to be legitimate. And I mean, that's also similar to, I guess, thinking about like a real life company in a building. If they're, changing building every day, well, then you don't really know who's actually inside that building. Whereas, yeah, if it's like a sort of reputable company and, like, yeah, okay. So if it's like a company and like, if you kind of know, well, this is their offices, well, then of course, yeah, you can trust them a lot more. So then if we look at dynamic IP addresses, so for other situations, e.g. personal devices, then we actually don't need a permanent IP address. Right, and in fact, for privacy security reasons, it's actually better if we don't. And I guess for this, so you can also think, well, why don't we need a permanent IP? Now, let's say if you've got a laptop, well, one, you're not going to keep that laptop on, 24 hours a day, 365 days a year, right? Yeah, of course, bro. Okay, yeah, okay. So people are going to turn it off. Right. Also, two, if you're actually changing the network. Now, since right, okay. So if it's a laptop, I guess, a phone, then if you're moving around, then as you're changing networks, well, then you're going to be assigned a different private IP, depending on what network you're on. Because let's say, for example, okay. So let's say on your home network you have, 192.168, .0.1, right? If, for example, you're the first person on that network. However, let's say then if you like go into the library or you go into your sort of classroom, well, probably there's going to be already someone that so probably someone has already taken that IP address, right? Therefore, you might have, I don't know, the IP address 100, the host ID 100. So because of that, like that's going to be why IP addresses have to change. Right, and I think this just says what we've kind of mentioned, that you're not going to have your computer on 24 hours a day, 365 days a year. So the problem with this, well, if every device had a fixed or static IP, then no one else would be able to use that IP, right? Even okay. So even when the IP is not needed, right? Yeah, when the device is turned off, for example. Which is going to be extremely wasteful. Right, okay, so there's usually two situations where dynamic IPs are used, right? We've mentioned this already. So your router will ask for a public dynamic IP from your ISP's DHCP server, right, when it's turned on, or okay. So when we say it, well, right, okay, right. So it here being the router, right? So when you turn on the router, well, your router is then going to ask for a public dynamic IP, right? Yeah, from the ISP's DHCP server. Right, also when you turn on the device, or when you enter a new network, then the individual devices will also ask for a private dynamic IP, right, from your router. And actually, you can say inside the router, well, the router is also going to have a DHCP server right inside, just like the router has, DNS server inside. Alright, so if we look at DHCP then, right, Dynamic Host Configuration Protocol, and I think maybe I made a mistake somewhere else where maybe I can, okay, so maybe I called that control somewhere. It seems here it's actually configuration. Although to be honest, so to be honest, in the exam, I mean, you're not really going to need to remember the name. Right, so the DHCP server, right, well, again, home router includes this functionality built in. Right, so this is responsible for, well, one, assigning a unique IP address to devices that request one. Yeah, for example, when a device is turned on, right, when it enters a new network. Right, and it does this by storing the valid IP range, and a list of currently used IPs. Alright, and then probably you say 3, well, then it's gonna, okay. So I guess this kind of relates to number 1. Well, then it's going to assign the IP, based, okay. So then it's going to assign an IP from the range that's, not currently being used. So hopefully that makes sense. Like, let's say we have, I don't know, okay. So let's say we have the network, right, 192.168, let's say 0, alright. Let's change it a bit, okay, let's say 5, and I don't know, .0. Now, if we, okay, so if we have the subnet mask, 255, right, 255, let's say 255 and 0, well, then, of course, what all of the sort of valid hosts, well, that's going to be what from 0 to, and what, well, right. So let's say, well, from 0 to 255. Now, again, if you want to be more specific, I guess you say, well, okay, so 0 is probably going to be reserved, right? 255 is also reserved. So in reality, what, maybe just, well, 1 to 254. So let's say, for example, I don't know, okay. So maybe, okay. So let's say 1 is already taken, right? Maybe 2 is taken, right? 3 is taken. Well, in that case, probably, okay. So probably then, if a new device tries to connect, well, then we can just assign it 4. Right, let's say then that 2 kind of leaves the network, right, after a certain amount of time, well, this is going to expire. right, then if a new person comes in, well, then of course, right, okay. So then of course the new device, well, that can then take this, host ID too, right? Since that's okay. So since that's expired, right, it's no longer being used. Right. So in terms of how we work out if it's expired, well, this is where the lease is going to come in. So a device will ask the DHCP server for an IP, and the DHCP server will grant them for a period of time. Right. Usually this will be between 1 hour to 1 week. And here, let's just assume 8 hours, right, to make the maths easier. Right, so the reason I've chosen 8 is because, well, this is kind of like Half-Life, right, everything is just going to half. So when half the lease time has passed, then if the device is still online, it's going to ask the DHCP server, right, if it can extend the lease. Right, so I guess here we didn't really mention, although it's kind of obvious. Right, if the DHCP server, responds to, right, yes, you can extend the lease, well, then it's just going to add a certain amount of time, to this lease time, before it has to ask again. Right, however, if the DHCP, so if the DHCP server is unavailable, or maybe, I don't know, for some other reason it's like denied the request, then the requesting device will then wait half the time and try again. So, e.g., if the initial lease is 8 hours, the device will wait the following time to try and renew the lease. So, first it's going to wait for 4 hours, right, then after 4 hours, right, then it's going to try and ask, can I, extend this lease, right? Can I continue using this IP address? Right, if it doesn't get a response, or, well, I guess, if it's denied, well, then it's going to wait, so then it's going to wait another 2 hours, right? Then it's going to try again. Right, again, right, if that's unsuccessful, well, then it's going to wait 1 hour, I try again, then, of course, 30 minutes, 15. So hopefully, so hopefully that makes sense how it's working, right? It's just kind of waiting half the time each time, right, and then just asking. So if you're thinking about the total time, so let's say, what if we've got 8 hours? Well, first it's going to ask after 4 hours, right? Then it's 4 plus 2, so then it's going to ask again after 6 hours, right? Then I guess it's going to wait 1 more hour, So then it's going to ask after 7 hours, obviously 7 hours 30 minutes, obviously 7, right? Sort of 7 hours 45, 7 hours 45 minutes, right? Just etc. And I guess if it doesn't successfully renew the IP in that time, well, then the IP will become available for another device. So this, like, IP recycling, being used by one device, right, then being available for another device. Again, well, that's going to be why it kind of alleviates the IP version 4 shortage. Since, well, one IP can be used by, right, multiple devices. Right, so to see an example then, we can see here my device was granted a 2 hour lease, right, 11:30 to 1:30. And I guess, here you can see that, if you see what the lease obtained, right, lease expires. Right, so after 1 hour, the lease would therefore hence try to be extended, because if we think, well, if the lease time was 2 hours, right, so then we're just going to wait half of that, which is 1 hour. So hopefully that makes sense. Right, and if we think about routers, well, routers are usually assigned a longer lease time by the ISP's DHCP server, right, than, let's say, private devices are, by the router's DHCP server. So why do you think that is? And again, just sort of pause the video, have a think about this. Right, so maybe you've realized that people are going to turn off their devices, quite frequently, or people are going to, leave the network, right? Maybe they go to school. Well, in that case, of course, so if they're taking their phone or their laptop, well, therefore that's going to leave their home network and, obviously, kind of enter another network. Right, in comparison, routers, well, I would say most people leave their routers on, 24/7, right, 365 days a year. Whereas, people don't really leave their computer on, permanently, right? Therefore, you don't need to give it a lease that, lasts that long. Because the thing is, right, if you give, so if you give a computer a lease for 1 week, but let's say you turn it off after 1 hour, well, then that lease is, so then it means that IP address is not going to be usable by anyone else for 1 week. That's why it makes sense. That's why it makes sense to give a relatively short lease time. For private devices or just devices on a single network. And actually, if you actually go into the router settings, so most routers, right, if you type in the router's IP address right into your browser, well, then you can enter the router settings, and you can actually change, for example, the default DHCP lease time, just to make it right longer or shorter, right, accordingly. Right, whereas if we think, well, okay, so the reason why we don't really want to give routers a short time is because, well, otherwise you'd have, okay, so otherwise you'd have a situation where, right, millions of routers will be sending the ISP, or yeah, well, the ISP's DHCP server requests, right, just asking to extend the lease, let's say every hour, right, and if we have that, well, that's going to add loads to the ISP's DHCP server. Right, therefore the ISP's DHCP server is going to give them a longer lease, right, therefore the routers will have to, check with them less. So effectively you can kind of think of it as kind of like saying, yeah, don't ask again for 1 week. Basically that's just going to reduce load, right, on the DHCP server, or yeah, the ISP's DHCP server. Yeah, so hopefully that makes sense. Alright, however, in reality, this is not necessarily true, right? So while in theory dynamic IPs offer more privacy for the user, and yeah, let's have a think like why that is. So think about why it's good for an IP address to, constantly change. So let's say then if your IP address is constantly changing, then it's harder to pinpoint a specific user and their activity. Right, in contrast, a static IP would have much less privacy because you can see, well, this person was on this website, 1 year ago, and let's say today they visited the exact same website. Whereas if you have someone's IP that's obviously changing, let's say every day or every couple of hours, well yeah, okay. So hopefully that's kind of intuitive, right? Why that's harder to track them, right? However, the reality is actually not so simple. So if we see this quote here, they say the typical lease time in the United States is roughly 7 days. Okay. So this is going to be the lease time for the router. Right. However, in most instances, the router will renegotiate this lease prior to expiration, and most households will hold the same IP address for longer periods of time. And while their research has discovered that many homes, that theoretically have dynamic IPs, actually hold the same IP address for multiple years, because again, what's happening? Well, since they're never turning off their router, well, then basically the router, okay. So as it says, okay. So the router is just what renegotiated and just extended the lease, since it's never being turned off. Right. So okay. That just kind of says that. Right. So I guess kind of ironically, then a simple way to improve the privacy could simply be to turn off your router, right, and hope that next time you turn it on, you should be assigned a different IP. Now, I've not actually tested this. I mean, this might be something interesting to test. Because I'm actually not sure, like, maybe the router is actually going to have, okay. So maybe the router is going to have some permanent storage where it will kind of remember the previous IP that it was assigned. And then when you turn it on again, it's going to try to automatically, continue using that IP. Or maybe it's not going to have any permanent storage, and basically when you turn it off, well, then it's just going to, sort of forget everything. And then when you turn it on again, well, then it's going to ask for a new IP. So yeah, okay, so that's something, maybe I'd want to test. But if it does that, right, so if it always asks for a new IP, every single time it's turned on, well, then again, that's why turning off your router, right, that could actually, possibly be a good way to get a new IP, right, and well, hence, improve your privacy. Right, so again, for example, well, the first one is just using the classroom Wi-Fi, right, the second IP, okay, so when I say IP, well, again, this is going to be the router's IP, because if we're thinking, well, this website here, and this is just like a, what'smyip.com, or some website like that, right, so these websites can actually see the private IP, or, of my device, they can only see the router's public IP, because, well, okay, so again, if we're thinking about NAT, right, if you remember what happens to the packets, so the packets, what we have, well, the header, the payload, the trailer. So in the head, what we have, the source and destination IP address. Well, that source IP address was getting changed, right, from, our private IP address, to, well, the router's public IP address. Right, now, again, I've just, okay, so I've just faked this again, just for, privacy reasons. But if you want to try this yourself, just type in, well, what's my IP, right, just to see, your, well, public IP. And with that, you should be able to get lots of information, right? For example, your location, your ISP, maybe other things like the, right, okay. So, well, the, right, okay, since it's the location, well, the city, the time zone, etc. Right, I guess in contrast, then, if we see here, well, this is going to be the private IP, right? Since, well, 192, right, just on the network. So if we think what these represent, well, the first two, yeah, root is public IP, right, provided by the ISP's DHCP server. Right, and then, well, the last one, and when I say the last one, I mean, yeah, this IP config/all, right, function or command. Right, that's going to be, well, my computer's private IP, and that's provided or, yeah, allocated, right, by the router's DHCP server. Alright, so if we just look at this, right, how we can actually change this, and again, if you want to try this, right, you can just go ahead. So this is going to be in Windows 11. So yeah, Windows 11, we'll just go to the settings, right, okay, so you're going to see something like this. Right, then if you go to IP assignment here, yeah, where is it? Okay, here we go. Obviously, yeah, click on this IP assignment, click edit, right, then you can actually choose whether you want, well, dynamic. So yeah, okay, so dynamic using, well, DHCP. Yeah, as we, okay, yeah, right, okay, yeah, so as we see here. Right, or on Windows, well, right, okay, so Windows they call static manual. And I think the reason they call it manual is because if, let's say, you're not familiar with networking terms, then maybe, well, manual and automatic, right, is, probably more easier, or, well, yeah, right, okay, not more easier, let's say easier, or, yeah, more easy, right, for a regular person to understand, right, rather than saying static and dynamic, which, yeah, maybe those terms they're not familiar with. And actually, okay, so for this we can see, well, DHCP, that's going to work both for IP addresses, right, and also, well, the DNS server. Yeah, okay, so we see then the current IP is this, and, well, it's assigned by the router's DHCP server. Right, if we want to change this, so then we can go here, we can change all these settings. First, I guess we want, yeah, right, okay, so first we want to find the subnet mask, right, default gateway DNS servers. Yeah, just so we can, type them in here, right, just so it works correctly. Now, the way we can get that, again, right, on Windows, well, IP config/all, yeah, just copy those relevant details, obviously, yeah, sort of, well, paste them here. Right, then we can choose the IP address that we want. Now, note the thing is, right, since the subnet mask is, what, 255.255.255.0, well, then what that means is that, okay, so we can then only change these last 8 bits. If we tried something like, well, let's say 192, right, .168, okay, yeah, 168, right, let's say .2, right, .200, well, this is going to be invalid, right, since, well, this, okay, so the subnet mask is saying, well, we can only change, right, these last 8 bits. Yeah, we can't change, this one here. Yeah, okay, right, hopefully that makes sense. Right, so even here, hiding some of the information again, privacy, or yeah, well, right, yeah, okay, so actually, this one is not for privacy, right, this is just to make the question harder. Right, so can you tell them which of these configurations is for a static versus dynamic IP? So yeah, well, between the left and right. Right, so if you had to think, well, let's just have a look at this. Right, okay, so if we're looking at the right one, well, the right one, for example, we can see here the lease. Yeah, we can also see... yeah, okay, right, okay, yeah, okay, so we can also see this, right, the DHCP server. Whereas, well, of course, yeah, right, okay, so the left one we don't see. So what we can say, well, the right one therefore is using, DHCP, right, dynamic IP, right, the left one, well, just using a hard-coded, right, static IP. Yeah, and I think that's just what we're saying here. Right, okay, so this one, I mean, hopefully people are familiar with most of this data now. And if you say the description, well, that's the right, yeah, okay. So the description, well, that's going to be the network card, or yeah, right, okay. So in this case, well, it's going to be the WNIC, right, the wireless network interface card, but yeah, wireless network interface controller. And again, as mentioned in other videos, well, obviously Realtek, right, just being the company. Well, obviously Wi-Fi. Right, 802.11, well, that's going to be the specification name for Wi-Fi. And I think the reason it's 802.11, basically that's going to be the month and year. So I'm not sure, is that going to be like maybe 1980? And then, well, 2 is going to be February. Yeah, I guess 11, I'm not really sure what that's going to be. Or maybe 11 is going to be the month, right? Maybe it's November. So this one, yeah, right, yeah, okay. So this one I can't remember exactly, but one of them is going to be the year, right? One of them is going to be the month. So I think probably 80 is going to be the year, right? Probably 1980. Obviously, what AX, right? Just different variations on the specification. Right, physical address, well, that's going to be the MAC address, right? Obviously DHCP enabled, right? Whether we're using, well, dynamic or static, yeah, IP addresses. Right, I guess, well, the IP version 4 address. Yeah, here, I guess, well, the IP version 6 address. obviously subnet mask, well, specifying how many bits are for the network ID, or how many for the host ID. Well, obviously, yeah, least obtained, least expired, right, to do with DHCP. Right, default gateway, well, that's going to be the entry and exit point for the network, so effectively just the router. Right, the DHCP server, well, that's going to be the server that's going to basically allocate, right, and kind of keep track of what dynamic IP addresses are available or not. And well, DNS, right, okay, yeah, okay. So DNS we've not looked at yet, but again, that's going to be responsible for converting a domain name, right, like google.com, right, into, well, google.com's IP address. Yeah, okay. And so one thing you can well, okay, yeah, right, okay. So one thing you can see with DNS. Now, if we look, well, this one is actually on our network, and if we look, well, this is actually the same as well. Yeah, the DHCP server, right, the gateway. So this one here is actually the router. Yeah, 192.168.1.1. Right, if we look at this one, well, here this is 192.168.2.1. Now, if we're looking at this subnet mask, well, that actually means that this 192.168.2.1, right, that's actually on a different network to, the network we're on. So I think actually in this case, well, this one is actually the school-wide, DNS server, whereas so not really the DNS server. Let's say the school-wide router, which also has DNS server built in. Whereas obviously, the second one, right, 192.168.1.1, right, that's going to be, well, the classroom. And actually, the thing is, right, you can also have just, completely different, so you can even have, public DNS servers. For example, I think, like, is it just, 1.1.1.1, right? So I think that's going to be Cloudflare's DNS server. I think Google just have, 4.8, sorry, so 8.8.8.8. Right, that's going to be, I think, Google's DNS server. And of course, there's also, right, many other public DNS servers as well. Alright, so if we try that again, so now we can actually run ipconfig/all, and since we've set that, well, here you can see, right, now we've actually successfully allocated this static IP. And if we try to go, well, let's say, taobao.com, we see, well, this still works, right, and it's still going to successfully navigate to this page. Alright, so this one, I guess, is a bit country specific. Okay, so let's think then, so who's going to own the most IP addresses in the world? And also, if you want to try for your particular country, well, all you have to do, go to this website, and we'll type in the 2-digit ISO code, kind of at the end of the URL here. So obviously, AU being Australia, if you're, whatever country, right, just type in, well, the, 2-digit ISO code, or the, so not really digit, right, just character, right, 2-letter ISO code. Alright, so in China, I guess you can see, well, China Net, China Mobile, China Unicom. So those ones, they're all going to be ISPs. It's got some, education. I guess some companies, well, like Alibaba, or AliExpress. I guess, right, various other things as well. Alright, but again, I would say, so again, if you're interested in seeing for your country, well, just go to this website, and this has, the same information, right, but for your country. Right, then if we look at, I guess, worldwide, so worldwide, well, China Telecom, China Unicom, I guess NTT, I think, what, Japan, like, probably Nippon, maybe that's true, or okay, so maybe that's Japan, or maybe it's not. What, Comcast, AT&T, well, that's going to be America, and actually AT&T, well, AT&T, so AT&T is going to be Bell Labs. And Bell Labs, they've actually made, a huge number of inventions, including, for example, Ethernet. Right, they also invented the transistor. I think probably they had a lot to do with Wi-Fi, maybe completely. They also invented, well, Unix, right, which obviously kind of, well, led on to, Linux, right, variations. Well, obviously Deutsche, right, that's going to be German. Times Warner, I guess, probably American, right, Verizon, I think American. Obviously France, well, KT, right, it's probably Korean. Okay, so there's actually a non-ISP organization that has even more IPs, and this one would be impressive if anyone can actually guess this. So let's have a look. So it's actually the US military, and they've got 307 million different IPs. Now, naturally, people, I guess, conspiracy theorists, people are wondering, well, why do the US military need, 307 million IPs? And what are they using them for? So, of course, well, some people are saying, well, it's the sort of, Edward Snowden, right, spying, all this kind of stuff. I think the reason they give, well, actually, if you think, back to ARPANET, well, this was actually developed by, the US military. So it kind of makes sense that So it kind of makes sense that the military, have a lot of IPs for themselves, since they actually kind of invented. So they kind of invented the internet, to an extent. However, this does also cause a problem because, well, then you have a lot of countries which have, barely any IPs. Certainly not enough, right, for all the people. Alright, so let's have a look at then some of the questions, right, recap. So what were some of the ways used to alleviate the IP version 4 shortage? And as always, well, just pause the video, have a think, and then, I'll show you the answer. Right, so first, well, subnetting, and hopefully you remember, well, subnetting are basically to specify how many bits are for the network ID, and how many bits are for the host ID, right, based on the subnet mask. Right, then private IPs, so let's say rather than every device having a globally unique public IP, well, now only the router needs that globally unique only the router needs the globally unique public IP, and the actual individual devices on that network, well, they only need a unique private IP, kind of within that network. Also dynamic IPs, so when you turn off a device, when you change the network, well, you don't need to keep the same IP, right? You can actually not use that anymore, and another device can then use the IP instead. So kind of IP recycling effectively. Right, then there's actually a fourth one. So IP version 6. Now this is going to be next class. Of course, well, we've not really looked at that yet. Right, then let's ask, well, what is network address translation and how does it help alleviate the IPv4 shortage? So again, pause the video, and this one's quite a long answer. Alright, so network address translation, so it's going to convert a private IP for a device to the router's public IP that is globally accessible by other devices. Right, network address translation is going to alleviate the shortage since, well, now not every device needs a globally unique public IP. Right, only the router and other nodes like servers, right, are going to need a globally unique public IP. Not end user devices. So I guess this is really just talking about the advantage of private IPs. Right, okay, then let's ask, well, what is a port? And hopefully this one's quite easy. So basically it's just an ID number that's assigned to a process that allows the operating system to transfer packets to the correct process when they're received. Alright, so it seems that animation is messed up there. Right, so I think the question was, well, how does NAT work? Right, how does network address translation work? So, right, let's just have a look at the answer again. Quite long. So the router stores a network address translation table, or network address translation, forwarding table, mapping the incoming packet's private IP port, to the router's public IP and port number, which it then kind of updates the packets with. So basically, what it's going to change the So it's going to change the source public IP and port. So it's going to change the packet's private IP and port, to instead be the router's public IP and port. Right, then when receiving a response, the router checks the public IP and port mapping, to see what private IP and port these packets are kind of intended for, and then it's going to forward them onto the correct device. Now, of course, when that device gets it, well, then the operating system, as we've seen here, then the operating system can then transfer those packets to the correct process. Alright, so I think a few more. What are static and dynamic IP addresses, and list some advantages of each. So let's say static, well, they're going to be fixed, they don't change, and because of this, they're going to be trustworthy, they're easy to access. I guess maybe say kind of simple to set up. You don't need to have, the DHCP server. Right, but then dynamic IP addresses, well, they're going to be assigned by the ISP or router, using DHCP, Dynamic Host Configuration Protocol. A device's IP can change, and that's going to help alleviate the IP version 4 shortage. Since, unused IPs are going to be recycled, used by other devices. Another advantage, it's going to be more private, because, if someone's IP is constantly changing, it's harder to track them, over a long period of time. So that was just the second point there. Alright, and then maybe the final question, so what is DHCP and how does it work? Alright, so huge one. So the dynamic host so this shouldn't be control, that should be configuration. The dynamic host configuration protocol provides a method of allocating private IP addresses to devices on a network. Okay. So that's going to be kind of what is it, right? Then how does it work? So DHCP servers will store a list of used and unused IP addresses. When you try to connect to a network, the device will request an IP from the DHCP server and be granted one for a given lease time. Alright, yeah, if, well, yeah, right, okay, so yeah, if, like, there's an IP available. Right, so once half the lease time has expired, the device will then ask the DHCP server if it can renew or extend its lease. Right, if not, it's going to wait half the time, right, try again. Yeah, if not, well, half the time again, try again, right, etc. Until either it successfully managed okay. So either until it successfully manages to renew the lease of the IP, right, or the lease time expires. And of course, well, if the lease time expires, well, then it's just going to be, kicked off the network. Yeah, it's not going to be able to connect. Alright, and then, yeah, I think that's everything. Alright, guys, so as always then, well, hopefully that video is useful. If you've got any questions, just ask in the comments, and I'll see you again in the next video.